Have you ever stopped to think about how your private cloud network actually stays private? I mean, you're sharing the same physical hardware with thousands, maybe millions of other people. So how do companies like AWS or Azure make sure your data doesn't just bump into someone else's? It really feels like magic, but it's not. It's an incredible feat of software engineering. So today, let's pull back the curtain and see exactly how it all works.
All right, so to really get a grip on how the cloud works, you first have to appreciate this massive shift that's happened. We've moved from a world of physical things you can touch and plug in to a world that's really defined by code.
And just look at the difference here. On the left, you've got the old way. We're talking about physically racking servers, plugging in a spaghetti monster of cables, manually configuring every single piece of hardware, a process that could seriously take weeks. Now, look at the right. That's the cloud way. All of that stuff, the routers, the security, the connections, it's all just software now. You can literally design and deploy a global network in seconds with a few clicks. It's a total game changer.
Okay, so if it's all just software, it begs the question, right? What happened to the actual hardware? If you're not plugging in physical cables or bolting down routers anymore, where did it all go? Answering that question is really the key to understanding the entire modern cloud.
It all starts with the most fundamental building block of any cloud network. It's your very own private space, and it's called the Virtual Private Cloud, or VPC for short.
So what is a VPC? At its core, it's your own little, logically isolated section of the cloud. Imagine the entire cloud provider is this massive, sprawling apartment building. Well, the VPC is your private, locked apartment inside of it. No one else has a key, and no one else can get in.
And this is exactly why people call it your digital real estate. Because inside your VPC, you are in complete control. You get to define the IP address space using something called a CIDR block, which is just a way to carve out your own private range of addresses. You design the layout, and you decide exactly how or even if it connects to the public internet. It is truly your private corner of the cloud, totally walled off from everyone else.
Okay, so once you have that piece of digital real estate, the next thing you do is start designing the internal layout. Just like you'd plan out the rooms in a new house, you've got to create different zones for different purposes.
And in the cloud, we do this with subnets. Think of a public subnet as the storefront of your business. It's connected to the internet, and it's where you put things like your web servers, the stuff that needs to talk to the outside world. The private subnet, on the other hand, that's like your secure, windowless back office or warehouse. It has absolutely no direct path to the internet, which makes it the perfect, safe place to keep your sensitive databases and internal applications.
So how does all the data know where to go? Well, that's the job of the virtual router and its route table. See, instead of a physical box with a bunch of blinking lights, this is just a piece of software that acts as the traffic cop for your entire VPC. And the route table, that's its map. It gives every single packet of data precise turn-by-turn directions.
All right, so we've designed our space, we've laid out the roads inside it, but now we need to talk about security. We need someone at the door checking IDs. We need the virtual bouncers. And here's what's so cool about the cloud. You don't just get one layer of security. You actually get two completely distinct types of virtual guards, and each one has a very specific job to do.
This table really breaks it down nicely. First up, you've got the security group. The best way to think about this is as a personal bodyguard for a specific server. And it's stateful, which is a fancy way of saying it's smart. If you let a request in, the bodyguard automatically knows to let the response go back out. Then you have the network ACL, or NACL. This is totally different. It's more like a big fence around your entire subnet, your whole neighborhood. And this fence is stateless, which means it doesn't remember a thing. You have to write explicit rules for traffic going both in and out. And unlike the bodyguard, this fence can have both allow and deny rules, which is great for blocking known bad guys right at the border.
Okay, we've looked at all the virtual pieces, the VPCs, the subnets, the security guards, but that still leaves our big looming question. How in the world does any of this work on shared physical hardware? It's time to finally reveal the trick.
And the secret is this. It's not one network. It's actually two networks, operating at the exact same time with one layered right on top of the other. The physical reality, the wires and switches, is called the underlay network. This is the massive grid of fiber optics and routers that everyone shares. Think of it like the physical road system in a city. But then, running on top of that, you have the software magic, the overlay network. This is the virtual layer, and what it does is create these private, secure tunnels for each and every customer. So even though you're all technically using the same roads, your traffic gets its own private teleportation system that no one else can see or use.
So how does this teleportation actually happen? It's through a process called encapsulation, usually with a technology called VXLAN. Here's how it works, and it's simpler than it sounds. First, your data packet gets created inside your private VPC. But before it goes anywhere, the system wraps it up inside another, bigger packet, kind of like putting a letter into an envelope. This outer envelope is what travels across the shared physical network. Once it arrives at its destination, it's simply unwrapped and your original private packet emerges, safe and sound, having never been exposed to the public network at all.
And that's the whole secret. That simple idea of encapsulation is what allows millions of customers to have their own private routing, their own firewalls, and even use the exact same private IP addresses, all while running on the same physical machines, without ever interfering with one another. This is really the heart of modern cloud networking.
But you knew there was a but coming, right? This incredibly powerful software layer isn't completely free. All this flexibility and security comes with a small but real performance cost.
Remember that wrapping process we just talked about, that outer envelope? Well, it adds a bit of data. A typical VXLAN header adds about 50 bytes of overhead to every single packet of data you send. Now, it's not a lot, but when you're sending millions of packets, it definitely adds up.
And this chart shows you the impact on speed. All that extra processing to wrap and unwrap packets adds a tiny bit of delay, or what we call latency. As you can see, a virtual cloud network typically has slightly higher latency than a dedicated physical one. Now we're talking about microseconds, that's millionths of a second, so it's incredibly fast, but it is a real measurable difference. But of course, the story doesn't end there. The cloud providers are in a constant race to eliminate this overhead, and they fight back with custom hardware, things like AWS's Nitro system or Azure's SmartNICs. These are basically dedicated chips whose only job is to handle all this network processing, offloading it from the main CPU. It's how they make the virtual network perform almost as fast as a physical one.
So, what's the bottom line here? The key takeaway is that cloud networking is one of the most sophisticated illusions in all of technology. It's this clever layer of software, the overlay, that gives you total flexibility and privacy, and it's all running on a shared, incredibly powerful physical reality, the underlay.
And that leaves us with a pretty fascinating thought. We've just seen how software can completely virtualize the routers, the switches, the cables, the very fabric of a data center. It really makes you wonder, what's the next complex, physical system in our world that's just waiting to be turned into a few lines of code?